All right. Hello, guys. Let's go ahead and let me get my pen. And let me switch back to both to one screen. There we go. Pen color. Let's go ahead with purple or magenta if some of the guys have trouble with that color. So we're going about the force that is required to keep the object going in a circle. Centripetal force. So what we have somebody running a model airplane, and basically it's one of these things that have guiding wires on coming out from the plane to the person in the middle. And this one doesn't have that much info on it, which is good. So model airplane, here's the mass, 3.2 kilograms, with a radius of 12 meters. Here's the airplane speed, 45 meters per second. That's kind of fast. So we want to know the force that the control line needs to exert on the plane towards the person to keep it flying in a circular motion. So here's the equation. Force is actually mass times acceleration. Here's the acceleration, the Vt over r. So remember, A is Vt squared over r. And so the force, and I screwed this up, sorry about that, mv squared over r, that's going to be the centripetal force. So, as the plane is circling around the guy in the middle, he has control lines, and the force is what he's exerting on the plane to keep it going in a circle. So let's look at the data again. 3.2 kilo, 12 meters. 3.2 kilograms, and we have 12 meters. And I think we need the tangential velocity, which is 45 meters per second. All right, so we got these three data. We do not need to do any changes. Mass has to be in kilograms. So the force that we're looking at is 3.2 kilograms times the velocity, and we're going to square it. Then we're going to divide it by 12 meters. So that's so force times acceleration. Let's look at the units: kilograms, meters squared over second squared divided by meters. One of the meters will cancel, so that's kilogram meters per second squared, and that's equal to newtons, which is force. So force is going to be equal to 45 squared times 3.2. and that's divided by 12. And the force is 540 newtons. And that's the answer for this problem. So if you have any questions, please let me know. Get a hold of me or during Scott time. Thank you, guys.